Okay, once again, I'm going to do a recording of this if you can't write fast enough. We're doing parabolas today. So we were supposed to start this yesterday and finish it today. I'm going to start and finish it today. So parabolas today, tomorrow, circles, ellipses, hyperbolas, and parabolas in polar coordinates. There's a review on Monday, which I've already recorded, and your test is going to be Tuesday. As a warm-up, I've got this equation over here, and I'll give you about 3 or 4 minutes to play with that. Let's talk in general. Can anybody tell me what conic section this is? How do you know? Same coefficient, same size. It's a circle, okay? So it is a circle, and because it's a circle, I would be asking two things. What do I need about circles? Center. That's all you got to do. So see if you can find the center and radius for this. Okay, center and radius. The completing the square process is a little bit more involved for this. And so if you're not sure what to do with the 16, I'll start you off with the x squares. I am going to leave a gap here, and the same thing with the y squares. The constant gets moved. When you're completing the square, you really want this coefficient to be a 1 and not a 16. So the process is this. You factor out that 16, so now you have x squared minus 3x. And it makes the problem a whole lot simpler to do. Complete the square using that. Same thing over here. You would take out the 16, and so now you have y squared plus 4y, and complete the square using the 4. Excuse me, that may be my doctor. Play with it. Yellow? Yeah. Got it. Okay, bye. Your last name isn't Jeep, is it? Okay, so hopefully this went reasonably well. You put a plus 4 here, and then you put a plus 64 here. Whatever you do on the left, you have to do on the right. All right, so half of 4 is 2. 2 squared is 4. So we put a 4 there, and we've changed the left side of the equation by 64, so that has to be 64. Do the same thing with this. We take half of 3, which is 3 halves. We square it, we get 9/4. 9/4, right? Half of this is 3 halves, actually negative 3 halves, but when you square that, you get 9/4, that's what you add, and then you have to add the same amount to the other side, but notice we're adding 36 to the other side, right? Okay, so once you've done that, now you've got this. We've got 16 times x minus 3 halves squared plus 16 times y plus 2 squared is equal to whatever the heck that is. What's that? 9. Okay? Now, the graphing form for circles doesn't have this 16 here, right? The graphing form was x minus h squared plus y minus k squared equals r squared. That's the graphing form. So what you suspect I might want to do with the 16? Divide it out, exactly. So when I divide that out, this now becomes 9/16, and now you can read off the center is the point HK, 3/2, comma, -2, and the radius is 3/4. Okay, that's the radius squared over there. Okay, radius is 3/4. Now, as circle problems go, that's at the difficult end, but once you've seen it, then you should realize, oh, I can do this. This is not impossible. I suppose I could have at the very beginning divided everything through by 16. That would have worked just as well. If I wanted to at the very, very beginning, just to clear that first piece, I could have divided by 16, and all the way across like this. Now that looks a little ugly, right? But now this is nice. This is 1, 1, this is 3, this is 4, and that's still 91/16. So you might want to try it that way. You're still going to get the same center and the same radius. Okay, so let's go back to the project at hand here. We're working on parabolas today. Parabolas come in 3 varieties. Ones that open up or down. These are ones that would have a vertical axis of symmetry. You might remember from Algebra 2 the axis of symmetry. Any parabola that opens up or down is a function, right, because they pass the vertical line test. We also have parabolas that open left and right with horizontal axis of symmetry. Obviously not a function, not a function. And lastly, there are parabolas that we're not going to study in this class that have an axis of symmetry on a diagonal. So they're certainly okay. This is not an illegal graph. It's one that we are not going to study. They're in your book under rotation of axes. In fact, it's in chapter 10. This axis of symmetry is rotated by an angle theta. And you can actually do that with trig. I'm not going to cover it in this class. You don't need it next year for calculus. But yes, all these conic sections can have vertical or horizontal or non-vertical and non-horizontal axes of symmetry. We're going to stick with these, okay? So opening up and down, whenever you see an up or down type parabola, I want you to think y equals x squared. That's in your basic library of functions. This is a function. We know that. If the parabola were to open downward, still a function, but now there's a negative x squared, right? So this is up, opens up, and this is obviously opens down. Opens down. To sort of distinguish the two types, vertical axis of symmetry or horizontal axis of symmetry, we should probably go ahead and just, right now, just discuss briefly. This is x is y squared, opens right. And this would be x is negative y squared. X is negative y squared, opens left. And I'll talk about those in just a little bit, but I'm going to start with the ones that are functions. So x is negative y squared, opens left. Remember your sample test. Again, I would suspect that some of you have already printed this out, but if you haven't, then you might want to. One of the questions on here was, could you identify, what's going on here? So this is a parabola. Now, which way does it open? Up, down, left, or right? Because that's what we're going to be doing. We're going to be graphing. This is a parabola. Does it open up, down, left, or right? This one was a parabola. Does it open up, down, left, or right? So let's look at both of those and sort of see what's going on. The first one said 8x squared plus 8y is 10. And the second one down there, second from the bottom, was x squared plus 8y is 10. And we agreed that both of these were parabolas. How can you tell? This is only one square term. Okay, one square term. Now, the question I just asked was, how can you tell which way these guys open, up, down, left, or right? So what you want to think about is anything that can be written like this, y equals x squared, that opens up. So let me start to play with this. I have 8y is negative 8x squared plus 10. And if I divide through by 8, right, I get y is equal to negative x squared plus 10/8. Anybody want to take a shot? Does it open up, down, left, or right? Down. Y equals negative x squared. So obviously there's some sort of shift going on here. But yeah, this one, this first equation here, 8x squared plus 8y equals 10, is a parabola that opens down. And if you do a similar, analysis on this, you would find it also opens down. So one of the things you need to have to do early on in the process of dealing with parabolas is to determine whether the parabola opens up, down, left, or right. So I want to start with parabolas that open up. Y equals x squared. This is up. Okay, some general terms to go with this guy. The turning point is called the vertex, right? This is the vertex. It sort of plays the role of the center of a circle or the center of an ellipse or the center of a hyperbola. We're going to be using the letters H and K for the vertex. So there is no center for a parabola, but HK is the vertex. If we have this one right here, the H and K are both 0, right? The focal distance, so here's my focus up here. This focal distance for the ellipses and the hyperbolas we call C, but for some reason they don't use the letter C with parabolas, they use the letter P. So think of this focal distance as P, maybe P for parabolas. The other thing that you should remember about parabolas is that the eccentricity is the number 1. By definition, eccentricity is 1. And if you remember the river and well problem, right, here's your parabola, there's the well, here's the river. The directrix down here, and yes, we're going to get into those terms again, directrix, those are the very straightforward illusions the magician does. Those are directrix. This distance is also P. So you just might want to note that the vertex is midway between the focus and the directrix. That's one of the things, characteristics of parabolas. Okay, now let's go to our sort of generalized parabola. This is the type form that we're looking at. Just like with circles, we match up the k with the y. So y minus k, x minus h squared. Okay? Okay, so the y and the k go together, the x and the h go together, just like with ellipses and hyperbolas and circles. There's a multiplier here we can include, and it's going to be 1 over 4p, p being the focal distance. I actually prefer this version. Some people like to put the 4p on the other side so that it looks like this, 4p times y minus k is x minus h squared. I don't care which version you use. I'm going to typically use this version, okay, this version, but certainly you can multiply both sides by 4p, and you don't have any fractions in the problem. Here, there's a fraction there. Okay, so let me go ahead and just throw an equation at you, and we'll graph it. We'll try to get where the focus is, where the vertex is, where the directrix is. We'll try to do all this stuff, and we'll do it of this form right here. I'll make k equal 3, so we have y minus 3, and for this, I'm going to do 1/8. By the way, anybody want to take a guess what p is? I'll give you 2 guesses. 2, 4 times 2 is p. Okay, and then x, let's do plus 1 squared. Okay, so here's an equation that's sort of handed to you, and your task is tell me everything you can about it. Draw a picture of it, right? Give me the vertex, the focus, the directrix, an accurate graph, typical parabola problem. Okay, so the first thing you would do is hopefully you'd be given a grid, some graph paper. On the practice questions, I give you graph paper. And the first thing you should do is locate the vertex. You can think center. It's not the center, but it's the vertex. And that's this HK number. So HK is the vertex. And for this problem, the H is -1 and the K is 3. So we have to locate that first. Okay? H goes with the X, K goes with the Y. So -1, 3. Let me redraw my axes here. -1, 3 is going to be our vertex. So -1, 3, there. Now, that's an important step. If you goof that up, most everything else you got is wrong. So really pin down the H and the K, and H isn't this number. That's the one that's made it up with the Y. H is coming from here, right? Made it up with the X. Okay, the second thing I want to do is I want to just get a really, really broad brush. Which way does this parabola go? Does it go this way? Does it go this way? Does it go that way? Does it go that way? Right? And we see y equals, this is a positive x squared. So it's like y equals x squared. This parabola is in fact going up. Now, that's not an accurate sketch. We got a parabola that goes up. Yeah, we got the vertex in the right spot. Yeah, but we got a whole bunch more work to do. Okay, so first thing you should go after is that focal distance. And that comes from here. Okay, so this 1/8 is the same as 1 over 4p. So if I just make those equal, 1 over 4p is 1 over 8. So 8 is 4p, so p is 2. That's the distance away from the focus, or from the vertex. So if this is our vertex point. If we go 2 up, there's our focus point right there, focus point. And if we go 2 down here, this is going to be our directrix. Okay, so you'll be asked for both of those. The coordinates of the focus, what's the ordered pair, and the equation of the directrix. This is obviously a horizontal line, so it's y is equal to 1. Okay, that's the directrix. There's our focus. Okay, and you could put the numbers in here. This would be 1, 5, right? -1, thank you. -1, 5, got it. Okay, and the vertex point we said was -1, 3. So far so good? Okay, so we have this parabola opening up. It's nice to get sort of a sense on how it opens up, and we can do that pretty easily if you remember the river and well problem. I think I'll post that back on your class page. You did it about a month ago when we were doing river and well stuff. If you remember, if this was the river and this was the well and this is a point that's the same distance away from the well as the river, there was another point over here. How many miles or steps do we have to go to get to that guy? It's the same distance away from the well as the river. 4. This is 4. This is 4. Okay, and that will be another point on the parabola. That will be another point. So let's see, 1, 2, 3, 4. This is down here at -5. So here we are right there. This is the ordered pair, -5, 5. And our parabola is fitting through this, right? There's another point over there that I can find. That would be 4 units going that way, which is pretty much out of my picture. It's over here at 3, 5. Okay, so that allows me to get a rather accurate sketch of my parabola. Now, by the by, since we have the equation, I could actually verify that that point, this -5, 5, works in here. It has to work in the equation. So let's just sort of check to see whether it does. A lot of times you won't have to do this, but it's not a bad idea. I'm claiming the point negative 5, 5 is on the parabola, it has to work in the equation. Let's see. 5 minus 3 is supposed to be, question mark, 1/8 of x, which is, what's that, negative 5 plus 1 quantity squared. Is that true? Well, better be, otherwise I screwed up my point. Let's see, this works out to be 2. Is that the same as 1/8 of, what's this, negative 4 squared? Negative 4 squared is 16, 1/8 of 16 is 2. Yeah, so it does work. Okay, so that point is on the parabola. Okay. There's the parabola that opens up. Let's look at the sample test again, or the sample test questions. Here's now, this is one that's on your class page. And so this one addresses a parabola opening to the right. Opening to the right, not opening up. We've done one going up, but now let's one going to the right. Tell them to stand up. Good. Yeah, now you can do this and stand up, and that way when you fall, yeah. You're obviously not writing anything down, so good, you've done this one. Parabola is opening to the right. So, x is equal to y squared, opens this way. Let's put the h and k in. X minus h or k? H goes with x. 1 over 4p, y minus k squared. Okay? Y minus k squared. So this is the form of a parabola opening to the right. The vertex is still hk. H goes with x, k goes with y. The p is still the focal distance. Let's put some numbers in here. X minus 2 is equal to 3 times y plus 1 squared. And our task is to graph it, find the vertex, find the focus, find the directrix for this particular parabola. Okay. How do we start? What point do we go after first? The vertex. You get the vertex first, and then you draw a rough sketch. Okay, the vertex for this guy is at 2, negative 1, right? Because this is minus h and minus k. So 2 and negative 1. There's our vertex. And now correctly decide whether you're going up or down, right or left. This again, I noticed that this is a positive 3. So this is like x is equal to a positive y squared, which opens to the right. Okay, so our sort of generalized sketch is looking like that. That's not sufficient. You do that, I may throw you a 1-point bone and maybe give you something. But I got to get more than that. Okay, so the next thing we have to do is calculate the focal distance. And again, this number, the number that's in front of the squared term, is 1 over 4p. 1 over 4p. So we're going to write that down. 3 is equal to 1 over 4p. Cross multiply, we have 12p is 1, so p is 1/12. The focal distance is 1/12. Okay, so let's see how that sort of plays out. We have our vertex. This is at the ordered pair 2, negative 1. And the focal distance is a little tiny bit, right? It's only 1/12 of a unit away. So it's like almost right on top of the vertex. The vertex is at 2, negative 1. Anybody want to give me a shot as to the coordinates here? It's 1/12 of a unit away. 2 and 1/12, comma, negative 1. Yeah, it's still negative 1. Okay, so here's my focus now. This is the focus. Did I tell you the story about the movie Armageddon? Yeah, but how did they get there? Yeah, how did they get there? You don't remember the movie. Okay, so the scenario was there's an asteroid hurtling towards Earth, and they're going to try to blow up the asteroid, but the only way they can get to the asteroid is go to the moon, and they do this slingshot thing around the moon. So it's like, here's the moon, here's the asteroid flying this way, and they're going like this, and they do this right around the moon, really, really close. Okay, the closer you get to the gravitational body, the tighter the turn. If you were far away from the moon, you would get this type of an effect. But they needed to slingshot around and catch up to the asteroid. That was the idea. When these guys are close together, what can you tell me about the parabola? Is it wide or is it really skinny? It's really skinny. That's the idea. Okay, so when these are close together, there's nothing wrong with that. That just tells me my parabola is going to be pretty skinny, like that. Watch the movie Armageddon and turn the volume down, otherwise you'll blow your eardrums out. It was really, really loud. Who was in that? You may remember. Bruce Willis, yeah. Okay, so we got the focus. What else do I need? Directrix. So the directrix is right here. By the way, how far away from the vertex is it? 112. Yeah, so it's right here. X is equal to 1 and 11/12. Vertical line. X is equal to 1 and 11/12. Got it? Sure, absolutely. I think this is easier to do, but yeah, 24/12 is 2, 23/12 is, in fact, that's probably more mathematically correct. 23/12. How about that? Got it? Okay. Now, so graphing these things, not terribly bad if they're in the graphing form, but what happens if they're not in the graphing form? Suppose I give it to you in the general form. Have a seat. So let's suppose we had x minus 2y squared plus 6y is equal to 4. And I said graph it. X, in fact, let's make this a positive to make it even more interesting. X plus 2y squared plus 6y is equal to 4. Now, notice that if you try to rearrange things, this looks like this. X is negative y squared, right? Because the y squared would go to the other side. There'd be a bunch of other garbage floating around. But this is the key. So does this parabola open up, down, left, or right? Left. Right. Now, again, I think you probably should write this down a lot. Y equals x squared, that's in your library of functions. Y equals negative x squared, sad face. X is y squared to the right, and x is negative y squared to the left. If you get those wrong, you're going to get a bunch wrong. So this one now is x is equal to negative y squared. So here's the first thing we're going to do. Let's rearrange the terms. So I have the x. I'm going to move this constant over here with it. And then I have minus 2y squared, and I'll move that over, so that's minus 6y. Everybody agree that's the same equation? Okay, now what I'm aiming for, remember, is this. I'm looking for x minus h, 1 over 4p, y minus k squared. So obviously I have to complete the square again, but just like the warm-up problem, I really don't want a negative 2 there. I want a 1. Just like the warm-up problem, we had a 16 there. I didn't want the 16, I wanted a 1. Okay, so what I'm going to do on the right side here is go ahead and factor out that negative 2. X minus 4, negative 2 times y plus 3y, leave a gap. Okay, so this, thank you. I'm trying to complete the square. I better have a square term. So now I have to complete the square. What goes in the gap? Anybody? 9/4 goes in the gap, right? 9/4. Now, how did that happen? You took half of this, which is 3 halves, you square it, which is 9/4. So I've changed now the equation. I got to add the exact same amount to the other side. It is a balance scale, remember. Here's your sort of graphic for any equation. You have this balance pan, and we've added something to the right. We have to add exactly the same amount to the left. Now, how much did I change the right side by? Anybody? I did not change it by 9/4. Wrong-o. -3 halves. I don't like that. How much did I change it by? -18/4, so that would be reduced down to -9 halves. Right. So notice that I changed the right side by -18/4 or -9 halves. That's what I've changed the right side by. Yes? So I got to do the same thing to the left side. -9 halves. There. Now it's balanced, and everybody's happy. Okay? So now let's go ahead and clean this up a little bit more. We've got x. This is -8 halves and -9 halves. That's -17 halves. This is -2, and this is y plus 3 halves squared. We're getting close. Can you tell me my vertex, the HK number? Vertex? HK? How much? 17 halves and -3 halves. Good. Okay, so there's the vertex. If I wanted to graph it, I would find that. This is what, -8.5, or this is 8.5, and this is -1.5. Find that point. I know my parabola opens which way? Up, down, left, right? Up, down, left, right. Which way am I going here? I am going left, like this. Okay. Oh, going to the left. And what's the focal distance? How do I get that number? Okay. So this number here is 1/4p. So -2 is 1/4p, which means -8. P is 1. P is -1/8. Now, your textbook actually does a directed distance. The negative means you're going in the negative direction. I'm sort of treating this as a distance, so I would just say the distance is 1/8. Yeah, it is to the left. So if you sort of imagine working with this one, you find your vertex point, which is over here somewhere. This is your vertex point. We know the parabola opens to the left, and the focus is 1/8 away. So like right here, this is going to be the focus, and your directrix would be over there. Okay? Now, I think what you should probably do with these guys is go ahead and practice some out of your book. There's a bunch of exercises in there. You can certainly take the one problem on the practice thing and work this guy out. I give you the vertex, I give you the directrix, and your task is to figure out what the picture looks like and also the equation. By the way, this is a gift. What is the eccentricity of the parabola? 1. You don't have to do anything. Just write 1. You get a point. You know how many points you get? 1. Yeah, amazing. Okay. No, because then somebody would write the eccentricity as 5, and that wouldn't work. Okay. Yeah, probably not. Any other thoughts, comments? Okay, we've got time for one more. Let's go to the book. To the book. And pull one out of there. Let me log in over here. Okay, so here's a bunch of problems which are useful. For all of these, this is in your textbook, 37 through 54. It says find the vertex of focus, the directrix, graph the equation by hand, and then verify it using a calculator. There are some tricks to graphing these on a calculator. Remember, ones that go up and down are functions, and you can just do it y equals. But if it's left or right, they're not functions, and you can't do y equals because there is no. Okay, so anyone see something that intrigues them? 39 and 47 are actually worked out in the back, the little pencil things, so they work out. Let's do this one here, 48. So we've got x squared plus 6x minus 4y plus 1 is 0, right? And the task is graph it, vertex, focus, directrix, and I'll throw an eccentricity just for a bonus point. That would be 1 bonus point. It's the eccentricity. That would be 1 bonus point. Okay, so this is problem number 48 out of the textbook. By the way, these are sort of cool too. These guys, in fact, we may want to do 55 at the same time. We'll sort of do both of these. This is 48. And 55, it just says, tell me what the equation is. And it has a parabola opening to the right. It has a vertex point of 0, 1, and it goes through the point 1, 2. And your task is to find the equation of that parabola. In fact, 55 is easier than 48. Let's do 55 first. Parabola, this is given as the point 0, 1, and it goes through the point 1, 2. What's the equation? How do I start? Well, I note, first of all, that it looks like this. X is y squared. Yay? Okay, the next thing you throw is the h and the k. H and k. So that would be x minus 0. Yeah, it's x. Y minus 1. Okay, so there's the h and the k put in. We have one more thing we have to figure out, and that's this 1 over 4p. 1 over 4p. Okay? Don't know what p is yet. Our task is to figure, because they don't tell us where the focus is. If they told us the focus was right there and we knew that point, this distance is p, but they don't tell us that. All they tell us is the point 1, 2 is on the parabola. Okay, so this is how you're going to figure out what p is. I think it's rather intuitive. Right now we have x is equal to 1 over 4p, y minus 1 squared, and we know this point is on the parabola. It has to fit in that equation. Just put that point right in that equation. And lo and behold, you get 1 is equal to 1 over 4p times 2 minus 1 squared. And cleaning that up, you get 1 is the same as 1 over 4p. So 4p is equal to 1, cross multiplying. So p is equal to 1/4, right? P is equal to 1/4. Now, once you have that focal distance, you just put that number right there. P is equal to 1/4, so here's the final answer. I'm sorry, put it right there. So we have x is equal to 1 over 1, y minus 1 squared. X is y minus 1 squared. Done. Okay? Pretty straightforward problem. Let's go to the one where we have to complete the square. This was 48. And again, I would encourage you to play with these at home. You've got a couple of days before the test. Half an hour a night just working one problem out of each section. Answers are in the back. They have a bunch of worked examples, including the applications. I have posted your test solutions if you want to look at those, but that's going to be Monday's class. So you might want to hold off on that. Okay, so the first thing I do is a broad brush. I've got an x squared, and the y is going to go to the other side. So it looks like this. Is that up, down, left, or right? That is up, right? Y equals x squared is up. Okay, so this parabola is opening up. And in fact, because I normally think of it as y equals x squared, or y minus k is 1 over 4p x minus h squared, the k matches up with the y, and I usually think of it this way. What I might want to do is just sort of move things around so that it sort of looks like that, right? So what I might do is take these guys and chuck them that way. So I have minus 4y plus 1 is negative x squared minus 6x, and then I don't like negatives anywhere, so multiply through, and I have 4y minus 1 is x squared plus 6x. So this is getting more and more closer to what I want. Okay? I really don't want 4y, I want 1y. So let me divide everything through by 4. Y minus 1/4 is 1/4 times x squared plus 6x. Okay, same problem. I've just divided everything through by 4, or multiplied everything by 1/4. Multiply the left side by 1/4, and then multiply the entire right side by 1/4. Okay, so again, I'm trying to shoehorn this thing into this pattern, and you really want to remember the patterns. They're on your handout on everything you want to know about conic sections, but we're afraid to ask. So now let's go ahead and complete the square. Y minus 1/4. I've already got that factored out. I've got x squared plus 6x. What's in the gap? You better say yes, or otherwise I'll say no in German. 9. I trust you see why there's 9 there. What do I have to change the left side with? How much? Positive 9/4. Okay, so the right side I put 9/4 there. The left side I put 9/4. Right? Whatever you do to the right, you have to do to the left. Okay, so now I have y plus, what's that, 2? 9/4 take away 1/4 is 8/4. Is equal to 1/4 times x plus 3 squared. Boy, wasn't this a nice problem? No fractions at all. Vertex, -3, -2. H is with x, k is with y. HK, alphabetical order. Focal distance. What's the p number? Focal distance. 1. Remember, this is 1 over 4p. P has got to be 1. P has got to be 1. And then just so that we've almost got all the stuff here, I suppose I want the focus and I want the directrix. And it's sort of hard to see right here, but if I had a picture going, it would be super easy. Here's the picture. 1, 2, 3, 1, 2. There's my vertex. And this parabola was opening up, down, left, right. Up, y is equal to x squared. So sure enough, the parabola opens up like this. And I figured out my p distance, the focal distance is 1. So the focus is 1 unit away. Up, down, left, or right. Up, focus is always inside the curve. There's my focus, that's the path, right? And the directrix is down here. So the picture sort of gives you the answer. You should try to draw the picture the same time you draw or work the problem. Here's the focus, -3, -1, and the directrix y is equal to -3, right? Okay. That be it. Let me shut this thing down.